All right. So first off, I'll start with a little introduction. Oh, nice. Always test your clicker. Start. Whoops. Yeah, all right. So what can you expect from this session? Well, this won't be an introduction to Service Fabric. If you were interested in that, you should have checked out Mark Fussel's session before. I assume you were all there, so based on that knowledge, I will continue here today. You will learn about partitioning and the problems you encounter in that area. And then, if there's time left, I want to talk to you about how you can change your code in such a way that it can be efficiently unit tested. All right, so before I start, a little bit about the programming model. So if you look at Service Fabric applications running on a cluster, you can see that services always are part of a application. An application can have stateful services and stateless services and other stuff too. But I will focus on stateful services today. And what you can see is that stateful services usually have multiple partitions, and they divide their state across those partitions. Well, why would you do that? Well, a single service instance can only use the resources of a single machine. So if the machine runs out of CPU power, then, well, you're done. If you want to go beyond that, you will need to come up with a way with a way to divide the workload. Well, you can do that by partitioning your stateful services. In that way, you segment your work across multiple workers. This means that your state will also be divided into chunks, and every replica will be responsible of maintaining that chunk. So no single service knows all the data. Well, the number of partitions is a variable, and while you are designing your service, it's indeed a variable. But once you are in production, it becomes a constant. You cannot change the number of partitions for a running service, unless you do tricks. I'll talk about it later. All right. So usually, stateful services use the Int64 Range Partition. There's also such thing as a named partition, but today I will be using the Int64 Range Partition. And it's important you know how that works. And the principle is quite simple. So there's an address space between Int64 min value and Int64 max value. And that address space will be divided across your partitions. So you see in the image, if there are two partitions, all the negative numbers will point to the first partition, and all the positive numbers will point to the second partition. Well, you can also see that if there are four partitions, that range gets cut into 4 pieces. So that means that every number that fits into the long range will always point to a partition, no matter how many partitions you use. All right, so looking at services running on your cluster, this is a simplified view, but what I want to show here is that you always have a primary replica of your service that has the part of the state. And the primary replica is the one that is writable. And there are also one or more copies of your partition, and these are called secondary replicas. And it's important to know that these service partitions are read-only. So you can access them for read, but not for write, because otherwise you would have to do conflict resolution all the time. If you write in 2 different places, then you need to merge that. And Service Fabric decided not to do that. So this is important in my analogy later. So to explain the problems you can encounter while partitioning your data, so how can you make good chunks of your data, I've come up with an analogy to explain this. And the analogy is about a monastery that makes a living by selling handwritten books. So one day this monastery gets an order, and the customer wants them to create a dictionary of 26,000 words. And it's okay if this dictionary spans multiple books, or multiple volumes. The reader has one constraint, so they only want to search one book for every word they look up. So for instance, they're looking for the word cloud. They only have to have to open one book in order to find that that word explained. Well, the monastery also has a bunch of constraints. The first one is that one monk can only write one book, and this is the single writable partition story I mentioned earlier. The average writing speed of a monk, because it's handwritten, you can do 1,000 dictionary words per year. So that's the word and the explanation. And furthermore, the monastery has 52 monks available for this assignment. Okay, now let's look at a bunch of strategies we can use to divide those words across the monks. So the first strategy would be to partition by the first letter. So you take the first letter of a word, let's take cloud, that's the C, and well, you match that C on the cover of the book, you know in which book to find it. Well, the consequences of this strategy is that you can write between 1 and 26 books. So you can put everything in one book, or you can put every letter of the alphabet in a separate book. This also means, because of the one monk per book rule, that you can employ at most 26 monks. And at a velocity of 1,000 words per year, you will be expecting completion within 1 to 26 years. 1 year if you employ 26 monks, and 26 years if you employ one monk. What you already noticed is that this is an underutilized resource pool. So we had 52 monks available for writing, but we can only utilize 26. To make matters worse, we can also see that the words of a dictionary are not distributed evenly. So there are way more letters using the first letter T than there are first letter X. So in reality, what you will see is that while monk M takes about 4%, 1/26th of 100, to complete his word in his volume in a year, monk T has to write for 4 years, and monk Z, he's done in 5 days. So what you can see is that you will end up with different books of different sizes and a very unevenly distributed workload. So we expect it on average to be complete in 1 year, but in reality we will be done in at least 4 years, even though we employ 26 monks. So let's see if there's a better way to tackle this problem, and this is the second strategy. And in this strategy we introduce a librarian. So whenever we are searching for a word, we will ask the librarian in which book to look. And the same thing applies when writing a word. So these 26,000 words on the backlog, every monk who wants to write one, he needs to ask the librarian in which book to put it. If you translate this concept to Service Fabric terms, you will introduce an indexing service. And whenever you're searching for the word cloud, you calculate some kind of index. This index will point you to a book, and you can already see that the number of partitions of books you can utilize here is now a variable number. So you can use one book, 26 books, but also 1,000 books. So using this strategy, the number of partitions is a variable again. Furthermore, if you have your index service forward your query, you will only have to do one service call to get the meaning of the word cloud. So the index service in this situation does not only determine in which partition to look, but it also executes the command or the query for you. All right, now how do we create a good index service? So let's first start with the analogy again. So a good librarian must distribute the words evenly across all books. So if we decide to go with 52 books, then the librarian needs to make sure that those 26,000 words are distributed evenly across those books, so that every book has about the same page count, and so that the workload is distributed evenly across all monks. So, for instance, if you now use 26 monks, you will be done in 1 year. And if you use 52 monks, you will be done in half a year. So using this strategy, you will be able to scale your services linearly. So translated to Service Fabric terminology again, you must distribute your data evenly across the partitions so that every partition is roughly the same size, so that every partition gets roughly the same workload. And again, so your services can scale linearly. Adding more workers will increase your velocity of processing. All right, so how do you do this distributing of load? Well, you can use a hash algorithm. So for instance, you take the word, you calculate its hash, and this hash will be a number. And we've seen before that the Int64 range partition is addressable by number. So as long as you generate a long value, you can always point to a partition. There's one rule though. The outcome of the hashing algorithm must be very well distributed. You want to distribute the load. In my graph you can see 4 partitions. You want to make sure that you follow the green pattern and not the red pattern. Not all hash algorithms output the same random outcome for every word you put in. So some hashing algorithms have a bias towards positive numbers, for instance. You want to make sure that your hashing algorithm does not do that. Great choices here are the FMV hash or the murmur hash. All right, so in reality, you will probably not create a dictionary, and maybe if you do, it won't be just a word you're adding. You usually add entities. In my example here, I'm using a user object, and I want to store that. So what would be the consequences of applying the hash to each attribute here? So if you hash by identifiers, you can make sure that all the records that have the same identifier end up in the same partition. Same thing happens to organization. If you hash by organization, all the data for that organization will end up in the same partition. You can do the same thing with location. So you can enable geographical queries. So if you want to see what's happening inside Amsterdam, you know for sure that there is a partition that holds all Amsterdam data. To complicate matters, backup and restore strategy can influence this choice you make here. So backup and restore works on the partition level as well. And if you have a requirement, for instance, that you need to be able to undo errors for a certain user, you may want to make sure that that user's data is inside one partition, and restoring any backups in that partition does not influence other users. So this is a very complicated matter. Also, the distribution of your data itself will also influence the way your partitions are used. If you only store 2 objects in a 4-node cluster, 4-partition service, then you will only ever use 2 partitions, or worst case, maybe even 1. But the question is, how bad is this for you? So low user load with uneven distribution is not necessarily a problem. The other way works the same. So if you have an uneven use of data, then you may also end up in an unbalanced situation. So suppose you are storing data for 2 users. One is the size of Amsterdam and the other one is the size of, well, maybe Grotebroek, where I come from. That's a tiny village. So even though I may use my username to get a good random hash, but because there are simply 2 bunches of records in your cluster, the load will be unbalanced. So size matters. Well, where do you put this librarian or indexing service? You have roughly 2 choices here. The first choice would be to create an indexing service inside the cluster, and it will get the same availability as the other services. Because it runs on the same hardware, it will have the same failure rate. So whenever your services are there, your indexing service is also probably there. The downside here is that you need to build and maintain the code that is your index service. This can be quite complicated, depending on the strategy you choose. You can also decide to put the indexing service on top of the cluster. This means that it's outside the cluster and it has a different availability. it does follow the buy over build strategy. So you don't have to invest in knowledge and time to create an indexing service. You can just take a product that is off the shelf. It can even add stuff like TLS offloading, user authorization, throttling, metering, dashboarding. So you get a whole bunch of stuff for free. Yeah, the downside here is that because the, in this case, API management solution lives outside the cluster, you will lower your overall availability because both systems need to be alive for your whole product to work. All right, so I've created a solution that features both. So I have an indexing service inside the cluster and also an indexing service on top of the cluster, and I want to show you that. I'm not recommending that it's a good practice to have both, but it's for demo purposes. All right. I will go to the different browser. Ignore this and ignore that. All right, so here you can see my Service Fabric cluster. Can you read this in the back? Yeah, all right. So I've highlighted the URL over there. So this is the endpoint that my services will have, because this is the endpoint at which the cluster is listening. Zooming in on that. You can see that this is my Service Fabric application, and inside here I have a dictionary running. And the dictionary service has a endpoint that is at a random port. And this will be relevant later. You can also see that I have an indexing service running here, and that's at port 80. So this means that I have two services running in this example. One is reachable over port 80, and the other one is reachable, well, not reachable, you would imagine. So my indexing service is exposed to the outside world, and my dictionary service is protected. So let's have a look at how I can execute methods on that endpoint. So this is Postman, and using this tool I can send a web request or do posts. And I'm going to use this tool to do a get first on the cluster. I've added some words before, so you can see whenever I'm calling the get operation on my indexing service and I'm looking for the word cluster, I get back a meaning. The same thing I can do for posting a new word. Maybe cloud, and then I'll post this. Oh, yeah, that's the demo got here. %, sorry, good one. Yeah, all right. So now I've added a word to my dictionary service. And obviously, whenever I want to look up this word, I can just ask my indexing service to go and fetch it for me again. So what you saw happening here is that even though I have two partitions running for my stateful service, my indexing service knew, based on the word, which partition to target. How this works is by hashing that word. All right, so let's do exactly the same trick, but now using API management. This is an Azure solution. So what I did here is I created an API application. I've added an endpoint here and an endpoint here. So get and post, similar as you just saw me do earlier. And I've configured the get to find me a parameter inside the URL. So in this case that means word, and obviously for the post that means both word and meaning. So these are my two variables. What I did then is I set a backend service. Yeah, that's readable, right? Okay. So I've configured inbound processing. And while this may look like a bit of well, weird stuff, this is actually my hashing algorithm. This is an implementation of the FMV algorithm, and this is being used on that parameter I defined in the URL. So that's request.matchParameters word. It calculates a hash, and the outcome of that will be used to determine my partition. On the bottom of the screen, you can see that there are SF attributes, SF service instance, and SF resolve condition. So this means that API management has knowledge of the Service Fabric platform. So these attributes were not invented by me. These are available in the product. So you can use Service Fabric together with API management out of the box. You just have to make a couple of rules to determine which partition to use. So there's good integration here. And this also means that even though my backend dictionary service is running privately, API management can somehow target it nevertheless. So you don't need to expose your dictionary service to the outside world in order to make it reachable through API management. All right, so let's do a quick demo of the test here. And I'll show you it works on the same backend. Yep, same answer here. And what's relevant here is that API management not only adds SSL for me, so the URL here is HTTPS, so I have a secure connection to my services now. But it also adds a authorization header here. So I need to pass my subscription key to be able to access this API. So it's not accessible publicly. So I've added a layer of security, actually 2 layers of security around my API. Well, using this service from Postman is very similar to what we saw before. You can see that the URL is now Azure API, meaning I'm targeting Azure API management. And I have the header here. And once I provide those secret, I can use that service. I haven't added the word API yet, but let's do that. And now we can fetch it again. All right, so these are 2 different ways of an indexing service. One is on top of the cluster using API management, and the other one is inside the cluster. So let's have a quick look at the one running inside the cluster. Show you some code. So this is my Service Fabric solution. I've opened up the dictionary service, but let's go to the indexing service first. What you can see is that the indexing service talks to the dictionary service. That is done by this operation create service proxy. And it does that by the partition it calculated from the word. The next step would end up at this dictionary service. And you can see that the dictionary service is using the state manager that comes with the stateful service to store my data. The hashing algorithm is over here. I've put it in a separate class, and you'll see why later if we talk about testing. And this code, well, you may believe me or not, but this is the same code as I put in the API management. So this is why both my indexing service on top of the cluster and inside the cluster have the same ability to find and route my requests and commands. All right. Well, what happens if you're in production, you did all your partitioning right, but still you have reached the limits. Your app became more popular than you expected. You need to expand your business. Well, it turns out that you can use the same strategy as we used for partitioning to deal with growth. So if you maybe if you want to add applications to your cluster, add nodes to your cluster, you cannot add partitions to a running service, but you can add new applications. And using, well, stuff from the URL, in this case I'm using the word app and dictionary service to point me to the right application and service instance. And I'm using the word cloud to find me the right partition. So a similar strategy can be applied. Just ask the librarian. In this case, the librarian would probably not use a hashing algorithm, but it would look up a word in some kind of a mapping table. For instance, you can have a table that says, well, if you're looking for app1 service dictionary service 1, you should be directing your calls to fabric / application 1 dictionary service 1. Fortunately, recently a DNS service was also added to Service Fabric, and making clever use of the naming rules for your URL, you can just directly translate those URL segments to DNS calls. app1.service1. In that case, you don't have to keep a mapping table. All right, so dealing with disaster, even though your services are running in a cluster, and the cluster is highly available, disasters can still happen. Your whole cluster could fail, or maybe there is a human error, so some IT guy deleting all your data from a service. So it makes sense to back up your data. I've already mentioned that backups work at the level of partition, so this may influence your partition choice. The good news here is that you can restore your data to a different service. So if you need to deal with a cluster-wide disaster, you spin up a new cluster, take your backups and restore them to that new cluster, and you'll be in production again. However, there's very little tooling available to help you with this. So backup and restore is a notoriously difficult problem in Service Fabric. So a couple of tips here. Store your backups outside the cluster. Right, so you keep your backups for big time disasters, so it makes sense to not store your backup data on the cluster that may fail. So if you keep them in a blob storage, for instance. And my Service Fabric project, Service Fabric Backup and Restore, it's on GitHub. It will help you with this. It will enable you to create backups and restore backups and put them in a blob store. And it's open source, so please contribute. All right. Doing well on time. So creating quality code. So we're leaving the architecture area now and we're going to the development area. The difficulties while testing is that whenever you test your services, they expect to be running inside a cluster. And that means that they expect the state manager to be there. And the default behavior of the state manager is that copying of the data to all the secondary replicas. So this won't happen if you're not in a cluster. What makes matters worse is that your services also expect other services to be running. So usually in a big application, you'll have services calling other services. And obviously in a unit testing scenario, those services are not running because you're not in a cluster. So how you can deal with this is by cutting the dependencies to those services. And you do that by passing dependencies to the constructor instead of creating those dependencies within the service. The next step would be to inject the cluster-based objects at runtime and inject fakes at test time. All right, let's apply this strategy to the services we've created and you saw before. So we have an indexing service and a dictionary service. The indexing service is calling the dictionary service, and the dictionary service uses the state manager. So these are the two problems I mentioned earlier. So how you make this service testable is that you use the constructor overload of stateful service that takes a state manager as a parameter. So the constructor you see in the examples is usually the one without this state manager, and that would mean that the service creates the state manager itself, and that makes it very hard to replace. If you pass it to the constructor, you can pass something else at test time. So you pass the regular instance at runtime, so the bold word new reliable state manager. That is the runtime object you want to use. But you can create your own implementation of reliable state manager replica 2 and pass that at test time. And if you make sure that state manager does not rely on the cluster, but stores state maybe in a dictionary or something, you can now unit test the dictionary service. It can soon become quite complicated to have all these dependencies injectable and prepared. So I want to tip you on Artifact. It has support for Service Fabric. It will allow you to create a container with all your dependencies inside of it and use that while creating your services. So have a look at that. Also, I've created another GitHub project, and it's called servicefabric.mocks. And this project will help you with all kinds of mocks you can use for unit testing. It has literally tens of mock objects available. And again, please contribute if you want. All right, now let's have a look at this indexing service. Remember that the indexing service calls the dictionary service. So we need to abstract away this communication. So the default way for services to interact with each other is by a concept called Service Fabric remoting. And that works similar to WCF. So you create a client-side proxy, you call operations on it, and you call those as if they were running inside your own process. You just do method calls, and they will be remotely executed. Exceptions and results will be marshaled back for you. So, but to create this proxy, there are two strategies. You can do that inline, and you can have a factory injected into your constructor, so you delegate that work. So again here, I'm creating my service. I'm passing the default instance service proxy factory here. So my runtime service will just use the default way of creating proxies. But at test time, I will pass a mock service proxy factory. This is one of the classes from that the project I mentioned earlier, and what it allows me to do is to return a fake proxy on demand. So I register, you can see that in the code, I register that dictionary service I made testable earlier. I'm passing that as a variable in this indexing service now. And the next step would be to actually execute that test. So bringing it all together. We can now use that dictionary service using the state manager in two situations. We can apply our unit test to that dictionary service, but we can also use that same marked dictionary service as a variable for our indexing service. All right, if this is a little bit vague, I can zoom in a little bit on the code, and you can actually see it running. So let's first look at the dictionary service here and run it. I hope it works. Yeah, takes forever. Well, that's a demo, guards. All right. Well, that's too bad. I'll just go over the code. So what you can see me do here is that I just create a dictionary service, and instead of passing the actual state manager, I'm passing this reliable state manager, but then the mock version of it. So this is just an implementation of that iReliable State Manager 2 interface. I created myself, and I use a list inside of it to keep my state changes. The next step is to add a word into that service, making it end up in that list. And then I look it up again, and then I will assert that the word returned is actually the word I put in. The next test would be a little bit more complicated. So I do the same thing as I did before. I create that fake dictionary service. I create a mock service proxy factory. I register my fake dictionary service. I pass that whole stuff to my indexing service. And again, I can add and look up the word and assert that it is the same word. Well, there's one thing I haven't shown you yet, and that is to mark away that dependency I have to the hashing algorithm. So in a testing situation, I want to have full control over my hashing algorithm. So I'm not going to use this default hash, but I've created a mark hashing helper as well. And this will just return the value that I configure it to return. So instead of having to deal with a variable here that will be decided on the way I test my stuff, I'll just make sure that this is also under control. And obviously I will pass that hash helper as an interface to my indexing service. So you will probably never see me create new objects inside the service. Whenever it's possible to inject it into the constructor, I'll choose that option so I can have full control over that dependency. All right. Well, that went quite fast. Let me see if there are more tips. Yeah. So the final tip is there are two ways to create this proxy. The first is to use the inline version, that is service proxy.create, and that is a static call, so it cannot be tested away or marked away. Always go for the proxy factory and inject that to the service. I want to notice a bunch of other sessions that may be interesting to you. There's a session about actor systems in Service Fabric by Sander Molenkamp. And there's also one about API management. If you became interested in API management now, there's a good session tomorrow morning by Chris van Sluisveld. If you want to look at the code I showed you today, or the packages I mentioned, go to my GitHub and they're all there. And if you have any questions, please come see me afterwards.